In this video, I will talk about direct proportional in Newton's second law. So Newton's second law states that the force acted on a body is directly proportional to the product of its mass and its acceleration. So what that means is, imagine you're in space and you've got a block of metal here. Okay, a block of metal here. Now, if you get your finger and push against this this metal block here, if you apply a force to it, if you push it, then this block of metal will accelerate away in this direction here. So you can think of it as the force acted on a body. So the metal block is the body here. So the force acted on the body. So you're pushing against it. So you're applying a force to it. It's directly proportional. It's directly proportional to the product. Product means one thing times another. So to the product of its. So this thing times this thing to its. So it's directly proportional to the product of its mass and its acceleration. Product means one thing times another. Ratio means one thing divided by another. So what this is saying here is the force acted on a body is directly proportional. So what this direct proportional thing is trying to communicate to you is that as you increase the force, you will also increase the combination of the two here. So this direct proportional thing here is saying that, well, if you increase the force, you will increase the combination of the two here. And then as you decrease the force, you will decrease the combination of the two. Okay, so as well, because in our scenario here, the mass of this block here is always the same. So in this scenario here, you can think of it as F is directly proportional to A, because we are looking at this one scenario only where the mass of this metal block is always the same. So we can think of it as this. So what it's saying is that you see, this directly proportional thing is a very good way of communicating that if you double the force, you would double the acceleration. If you triple the force, you will triple the acceleration. If you halve the force, you will halve the acceleration. So this directly proportional thing is just a very good way of communicating that. It's a very good way of communicating how one thing here is related to another thing here, the acceleration. You see, you also need this m in here, because imagine a scenario where you have a lorry, okay, a lorry floating in space, and a car floating in space. You see, you do need an m in there, because you can't just write F is directly proportional to A. It's not a very good law. The reason why we can do it earlier is because our block of metal, we just looked at one scenario where the mass is always the same. Well, if you want to encapsulate all scenarios, then you have to use F is directly proportional to the product of its mass. You need this m in here, because you want to communicate. You want to come up with a law where it will satisfy all conditions. So you have to satisfy this lorry, which is M1, and also this car, M2. So you do need this M in here, okay? Because it has to be true for all scenarios. So it has to be true for the lorry and for the car. In our earlier scenario, we just looked at one scenario, so we can simplify it as F is directly proportional to A, because we only looked at one scenario. But when you come up with a law, it has to work in all cases. So you need this M here, so that it will work for the lorry and the car and a spanner and a hammer and anything else. So you need this M in here. But because we just looked at the block and only the block, so only the metal block, so we can simplify it to this, as long as we only talk about the block. In short, you do need this M, okay?